The Rock Lighthouse, one of the most heroic feats of engineering in maritime history.
You're out there fighting the elements, you're fighting nature on the front line.
Built to save the lives of thousands at sea.
There was a lot of shipping lost.
In the face of catastrophic storms.
The day you turn your back on the sea is the day you're going to die.
So how did they build them?
Whoa!
I'm Rob Bell, and I'm going behind closed doors to uncover staggering tales of innovation, epic adventure.
This is over 300 degrees, this lead I've got in here, right?
And danger. To reveal the secrets of some of the most extraordinary structures ever built. This time, on a deadly reef in one of the most hostile locations on Earth.
I just thought, this is madness.
One man strived to achieve the impossible.
He had an absolute sense of mission.
It was rather like putting man on the moon in the 1960s.
With technological innovation.
It's a wonderful story, actually.
And pure determination.
They were hard-working men.
Still standing after 200 years, it's been described as one of the 7 wonders of the industrial world.
Everybody said, oh, you can't possibly build it, but they did it.
But how did they build the Bell Rock Lighthouse in the fearsome North Sea? Stretching over 11,000 rocky miles, the Scottish coastline may look beautiful, but powerful currents, perilous seas, and sudden storms can easily catch out unwary mariners. Not to mention the sharp rocks hidden beneath the waves.
For centuries, this wild coast has condemned thousands of ships and countless sailors to a grim, watery grave in the bitterly cold North Sea.
11 miles offshore lies one of Britain's deadliest reefs. The Bell Rock, a jagged cluster of stubborn sandstone, only visible at low tide, threatened wreck and ruin to all who sailed these waters. Lying on busy shipping routes into Dundee and Edinburgh, it played havoc with trade along the whole east coast. During the 18th century, 6 ships were thought wrecked here every year. These rocks struck horror into the hearts of seamen and were about to claim one of their biggest ever scalps.
In 1804, on a routine North Sea patrol, the 74-gun HMS York was making her way up the east coast when she foundered on the Bell Rock, sinking with the loss of all 491 hands.
After countless other disasters, such a blow to the British Navy couldn't go unaddressed. Angry voices in Parliament demanded something must be done. It was from here, in Arbroath Harbour, that the brave men who signed up to tackle the problem would wave goodbye to the safety of dry land. More than 2 centuries later, the solution they came up with is still standing today.
Wow! Well, they don't come more sea-washed than this.
This reef stretches for 1,400 feet, but much of it is permanently hidden from sight. And at high tide, the whole thing can be 16 feet underwater.
But this lighthouse was completed in 1811, and ever since then it's withstood everything the North Sea has thrown at it. And it's never needed one single stone replacing.
But at the start of the 19th century, building on a submerged reef, far out to sea where huge storms destroyed all in their path, was considered utterly impossible.
So how did they even start?
In 1804, this desperate problem became one man's chance to make his name by taking on the most daunting challenge of all. Robert Stevenson was a young and ambitious engineer. Still relatively unproven, he was determined to establish that something could be done.
Robert Stevenson, he had an absolute sense of mission and was entirely self-made, but had a brilliant engineering brain, genuinely brilliant.
Stevenson was a rising star who'd overseen construction of his first lighthouse at the tender age of 19.
He was very sure of his abilities. He believed that he was put on earth by God to mark this reef.
With the backing of John Rennie, one of Britain's most eminent engineers, Stevenson's wild dream got the go-ahead. As the man in charge of work on the rock itself, he was set to take on the most daunting challenge in the engineering world.
The Bell Rock was the construction that was going to make or break Robert Stevenson's reputation.
But in 1794, when Stevenson persuaded a brave fisherman to bring him out here to the deadly reef, conditions meant that they couldn't even land on the rock, let alone plan how to build a lighthouse.
The biggest challenge of building the Bell Rock is the fact that it disappears with every tide. It was rather like putting man on the moon in the 1960s. It was just doing something that really hadn't been done before.
When work began in 1807, there were only a handful of rock lighthouses in the whole of Britain, and none of those rocks were submerged at high tide. 20 miles off the Welsh coast, the Smalls Lighthouse was built on 9 oak and iron pillars. Stevenson is said to have described it as a raft of timber rudely put together. He did consider a similar design using cast iron pilings, only to reject it for the high maintenance it would require. But 9 miles off the Cornish coast, the Eddystone Lighthouse had been completed in 1759. Its engineer, John Smeaton, had proved a granite stone tower could withstand the harshest storms of the English Channel.
Stevenson was to draw inspiration from both of his predecessors, but building in the North Sea, he knew he'd have to do better.
With nowhere on the rock to take refuge or store materials, Stevenson established a pattern that was to become his hallmark. He engineered a solution. He commissioned a works boat, the Smeaton, named after his hero, the designer of the Eddystone Lighthouse. Anchored off the rock, Stevenson and the men would eat and sleep on the ship, saving dangerous and exhausting trips to shore and back. But life on board wasn't always plain sailing.
These men were sick everywhere. Even Stevenson on occasion was feeling the effects of the sea, and he was very much used to sailing in conditions like that. You can think of the waves coming over the ship as well. It was often getting flooded. It sounds miserable to me to have to be wet when you're at home and wet when you're also working as well.
But life on the reef was no picnic either.
The sandstone on the Bell Rock was both jagged and awkward. It was also spectacularly hard, meaning tools would blunt within minutes, and the progress on foundations was painfully slow.
Stevenson came up with a surreal solution. He brought a blacksmith with him onto the reef.
With a forge and an anvil bolted down to the rock, tools could be sharpened on location. The blacksmith sometimes continuing on at his anvil up to his knees in water.
But the hardness of the rock wasn't their only problem.
As the hole slowly took shape, it would fill with water at every high tide. On every shift, it took a team of 20 men just to pump the hole dry, while another team picked away at the stubborn rock. And even at low tides, frequent large waves would wash right over the reef, filling the hole again.
In order to build something there, you have to get onto the rock at low tide, hammer away frantically, and then jump off when the tide starts to rise. They had to run, literally. to catch the boats before they were drowned. It was as simple as that.
After a close call when a drifting boat left them marooned on the rock with the tide rising fast, it was clear they needed a better solution. But Stevenson had a plan. He would build a temporary barracks on the rock itself. Like the Smalls Lighthouse off Wales, it was raised above the reef on sturdy oak beams to allow the force of the water to pass beneath. This structure could also act as a temporary lighthouse and was known as the Beacon.
Once complete, it was the beacon that would house Stevenson and his men, making it easier to get to work on the rock and provide them somewhere to retreat to for safety if need be.
The team that were on the Bell Rock, they were hard-working men, putting up with difficult and dangerous conditions, happy to climb into that refuge and wait for the tide going down. And in the summer months, they would be working all the daylight hours that were available.
The men endured nervous nights in terrible storms, sheltering in the beacon. But the main lighthouse needed to be a tall tower capable of sending a beam across the sea for decades. And Stevenson's design for that couldn't have been more different. It was to be built of huge granite blocks that could weigh over a ton. As winter approached and the weather worsened, work on the rock was suspended. But Stevenson knew his next problem was to be a Herculean task. How to raise up 1,300 tons of granite on the reef.
To build a stone tower in the middle of the sea.
The Bell Rock Lighthouse has been described as one of the 7 wonders of the industrial world. Robert Stevenson was the resident engineer who oversaw building 11 miles off the coast of Scotland on a jagged reef, submerged at high tide by the stormy North Sea.
Robert Stevenson was an innovator. I mean, he really was at the cutting edge of engineering and wanted to really push the boundaries and prove that he could overcome the elements.
In the second summer of building on the Bell Rock, Stevenson faced a monumental problem. How to move 1-ton blocks of granite into position on a slippery, tide-washed reef.
Each stone had to be unloaded from the Smeaton onto a smaller boat, bobbing around precariously in the waves. Then these massive weights were brought in as close as possible to the reef before being unloaded onto the rock and carried across it to the tower.
Lighthouses were still frequently swept away in high seas. But by locking the stones together with dovetailed joints, each one was anchored by the weight of all the others. Placing them was a laborious, delicate job, and with so little time to work between tides, they desperately needed to speed things up.
When you're out there, you have to figure out a way of making the machinery to make something like the Bell Rock buildable.
Arbroath's Signal Tower Museum was originally the Bell Rock's shore station.
What have we got here, Caroline?
So this is Robert Stevenson's account of the construction of the Bell Rock Lighthouse.
That's really, really exciting. So this is an actual copy from his. This isn't a contemporary copy.
Handwriting as well.
When did he have the time to do all this? Considering
he was a very busy man, yeah.
So what have you got? I mean, this is a whole volume.
Oh, this is incredibly detailed. You can see he's gone into the whole construction of the entire thing.
Stevenson built a standard sheer crane on the reef to lift stones out of the pram boats. But getting them onto the rocks was only the start of the challenge. To move the granite blocks safely and efficiently across the jagged, slippery surface, his team constructed an elevated railway on the reef, carrying them from the landing point to the tower's foundations.
What else have we got in it? Oh,
so this is the movable beam crane.
And this was the crane that was out on the Bell Rock itself, was it?
Yes, uh-huh.
The blocks had to be precisely manoeuvred into position as quickly as possible. So Stevenson's team invented the jib arm crane. The adjustable arm and the rotating base made it far more manoeuvrable than existing cranes. But it was supported by guy ropes, and as the tower grew higher, there wasn't enough room on the reef below to anchor them properly. So Stevenson's team simply invented another new crane, and the principle they came up with is still in use on building sites around the world today. The balance crane used a counterweight to balance the load of the stone and could be lifted as high up the tower as building required.
I think the more you delve into it, the more that you see that, yeah, Stevenson's hand is all over this. He's this polymath, this Renaissance man, this master of perfection. And that is so clear when you look through this document here.
The rock was a hive of activity, a most pleasing sight for Stevenson, who in the middle of the ocean described the scene as having a very curious and fanciful appearance.
Any non-local sailor coming past here at that time of construction must have had to blink or look twice at what they saw. A group of men out here, seemingly marooned in the middle of the sea, with smoke pouring out of the forge and drifting across the reef. Wagons being shifted around on a small railway, all in the middle of the barren North Sea. It must have been like some kind of crazy mirage.
Having worked out how to get the stones into place, Stevenson's next problem was sealing the joints. Dovetailing held the tower together, but it still needed mortar to stop the sea getting in. And if ice was allowed to form between the granite blocks, it could potentially damage the stone. Back in the 1800s, most building was done with a straightforward lime mortar that would take weeks to fully dry, and out on the reef, there'd be no chance of it setting before it started to wash away. But Stevenson knew of an ancient technology invented by the Romans, its secret ingredient, volcanic ash. At Aberdeen University, Professor Donald McPhee is an expert in the chemistry of cement.
The Romans were credited with quite a lot of engineering successes with cement, and indeed the volcanic ash that we are using today will have the same sort of properties as the volcanic ashes that gave them the opportunity to build marine structures, so harbours and so on.
By heating limestone, you make quicklime, and when you add water, you get a lot of heat.
Now, maybe you can see the water boiling there. This is a reaction called slaking. The thing that's important in terms of those Stevenson cements is that the slaked lime itself is reactive.
And when our volcanic ash is added to the mix, this reactive substance achieves something extraordinary.
In the presence of the aluminium and silicon ions that come from the volcanic ash, there can be other reactions to produce new products that give the long-term durability of the structure as a whole.
This putty-like consistency made it less likely to wash away as the tide rose, and the final mortar, mixed with sand to prevent cracking, would set within a few hours, even underwater. In fact, prolonged exposure to water actually helped this cement grow stronger and harder, making it the perfect material for building in the middle of the ocean.
You know, it's a very challenging environment, and you know, there's an element of excitement about it, which I would probably have loved to have had the opportunity to participate in. I would certainly have applied for a job if I'd been around at the time.
In 1810, after 4 years of work, the final stone was laid on the finely tapered top of the tower.
The tower's shell was complete, but when it came to its light, there was one crucial concern.
Once lighthouses begin to proliferate, you have a real problem about how you tell one from the next. And there had been a famous incident of a big wreck where a ship had sailed towards what they thought was a lighthouse, and it turned out to be a lime kiln.
On a boat in the dark, how could you tell a lighthouse from any other structure? Stevenson knew of a way. He made the Bell Rock Scotland's first ever rotating light. I've come here to the old Kinnaird Head Lighthouse to see how it would have worked. And to give you a clue, walking up these stairs feels like climbing up the inside of a giant grandfather clock.
So what have we got here? What's this?
Well, we're in the light room now, and we have our hyperradial lens and also the machinery which will rotate the lens.
This is what's caught my eye, this beautiful bit of mechanics.
The original ones were actually made by clockmakers in France.
So we've got all these gears and teeth and axles and chains. And are those the chains that we saw on our way up there in the middle as we spiraled around?
Certainly, the chains descend all the way down the tower. They're actually the most important part of the machinery because from those chains a weight is attached and that will pull down on the chains, pull around all the cogs, and that is what rotates the lens.
Is there any chance we can actually get this going here now on the machine?
Oh, certainly, yes.
The descending weight kept the keepers on their toes. It was essential to wind it back up before it reached the bottom, and that had to be done here at least every half hour.
And the weight takes over.
And it doesn't surprise me that you tell me the first mechanisms like this were built by clockmakers, because this was also about precision in making this go around at a precise 30 seconds per rotation. It's all about timing.
It's all about timing.
As more and more lights adopted this system, each one was designated a unique flash pattern. So even at night, mariners could be sure which lighthouse was which.
The lens had to produce a flash every 15 seconds. That was the keeper's purpose for being here.
Yep.
So if he can't do that, there is no point in him having his light go round at all.
Yep.
On the 1st of February 1811, the Bell Rock Lighthouse was lit for the first time.
The light actually meant that mariners instantly had a reference, a beacon, and they knew the reef was there. And it was literally night and day in terms of safety.
The Stevenson name was made by the Bell Rock Lighthouse. He became a celebrity overnight. It really cemented the family name as being among the best lighthouse engineers in the world, if not the best.
I mean, what is extraordinary about all these people is that they looked at things like the Bell Rock. Everybody said, oh, you can't possibly build it, but they did it.
The completion of the Bell Rock's construction was far from the end of this iconic lighthouse's engineering innovations.
The Industrial Revolution meant more ships than ever braving these stormy waters. And with unlit rocks still lurking all along this deadly coastline, if more lives were to be saved, Stevenson's light would need radical new technology. The completion of the Bell Rock Lighthouse in 1811 had made Robert Stevenson's reputation.
It took a lot of planning, it took great engineering skills. It is definitely a feat of Scottish engineering.
But with deadly danger all along this coastline, and vast areas of ocean still unlit, Stevenson knew lighthouses needed to do more. The light on the Bell Rock didn't just mark the reef, it also helped mariners fix their position. So it was vital they could see it from as far away as possible. But making the lighthouse more powerful would require a giant leap in technology.
In the early days, the light source in a lighthouse was simple technology. It pretty much followed the kind of lighting you'd find in the home. Candles and oil lamps. The burning question was how to increase their brightness.
Simple reflectors like these, developed from those used on street lamps, had greatly increased the strength of early light sources.
This concave bowl, lined with mirrors, would reflect any light emitted behind or out the sides of this burning wick in the middle here and redirect it forwards. increasing the power of the lamp in this direction. This meant that a basic oil lamp like this, a flame burning on that wick, could be seen for up to 10 miles, giving a respectable warning to any unwary mariners.
Well, the Bell Rock Lighthouse, of course, is 1811, and the first lighting system would indeed have been very good, silvered parabolic reflectors with argand lamps. And actually, they were really very, very efficient.
As ever, Stevenson, the perfectionist, wanted more. And this is the game-changing innovation that revolutionized lighthouses, the Fresnel lens.
Stevenson worked tirelessly on lighthouse development, making frequent research trips to investigate the latest innovations. But what he saw in 1824 was a blinding revelation.
Stevenson went on a fact-finding mission to France, and at the Cordouan Lighthouse on the Atlantic coast, he first saw the technology that would revolutionize the capacity of lights around the world.
The Fresnel brothers had pioneered the use of a lens positioned in front of the light. This early example of their work magnified threefold the power of the beam of this flagship French lighthouse. Over the following decades, Stevenson and his sons helped develop their lenses and introduce them to the Northern Lights. The old Kinnaird Head Lighthouse still boasts a working Fresnel lens. It's been superseded by the automated LED light next door. But they'll be turning it back on for me tonight, so I can see for myself what difference the lens made. We've placed a naked light at the top of the lighthouse.
So that light up there is a bit of a comparison test.
From across the bay, you can see that our bulb isn't nearly as strong as the bright flash of the modern lighthouse's beam. But using a bulb with the same strength as our test light, can the Fresnel lens match that modern technology?
Here it comes. What I'm seeing down here is nothing compared to what the lens is projecting out across the horizon.
The Fresnel lens concentrates the strength of the light by focusing its rays into a sweeping, powerful beam, creating a bright flash as it crosses our vision. That beam is visible from 25 miles away, making it more than a match for the modern light beside it. But how does this lens magnify the power of the light so greatly?
Here I have a laser. Let's turn that on. Now that single beam represents a single ray of light which heads off in a very specific direction. And I have here two more lasers which I'm going to set up heading out in random directions. Let's pop one out there and this one out here, representing light beams from a light source that are going off in all different directions. But I want them to head out to sea between my two goalposts to line up with this laser beam here. So I bring in the prisms. So with my two light sources here going through prisms, I've got a more intense light heading in that direction. And in a lighthouse, the Fresnel lens is made up of loads and loads of prisms all around that light source to focus and concentrate the light energy in one direction so that it can be seen for miles and miles heading out to sea.
Robert Stevenson passed away in 1850, but he left behind him a dynasty of talented engineers, and his family continued his remarkable work on the northern lighthouses. But they had a complex new problem. These phenomenal lenses were incredibly heavy. Turning them created enormous friction. Wheels and bearings had to be constantly replaced, and they could only rotate at slow speeds. It was nearly 70 years before a solution was put into practice. And I've come here to the National Maritime Museum of Ireland to see it for myself.
Wow. To come into an old church and be confronted with this. I have seen the light.
Installed at Dublin's Bailey Lighthouse in 1902, this Fresnel lens weighs in at a whopping 10 tons. But that's not actually what I've come here to see.
It's quite hard to take this all in. I mean, you've obviously got the enormous lens on the top up here, but what you can't see in here, which is equally fascinating, is there's a giant donut-shaped trough or basin in here that's filled with mercury. And then the lens is attached to a great big donut-shaped ring, which then sits on top of that mercury.
Nigel Teggin is a volunteer curator here at the museum.
Having invented, really, the Fresnel lens, with that came another problem as to how you were going to manoeuvre this great big weight.
Yes, that's true. So they came up with the idea of floating it in mercury. And in that optic there, we have 25 pints thereabouts of mercury. And
I'm trying to imagine that lined up on a bar, 25 pints of mercury.
Well, you wouldn't carry it very far.
No.
The mercury bath had a twofold advantage. It could carry more weight and turn it more efficiently. Faster rotation allowed flash patterns to speed up, and lighthouses could be recognised far more quickly. Exposure to mercury can cause serious health problems, but under laboratory conditions at Aberdeen University, I'm getting a closer look at what makes it so special.
So tell me a little bit about the properties of mercury. It's a bit of a unique metal, isn't it?
Yeah, it's nearly 14 times as dense as water.
Yeah, that's what I was hoping for. There's a mass to that. You can feel the momentum as you move it. I mean, that is weird because it's so heavy, but it's a liquid. That is so odd.
So as we're pouring it, we will have to be careful and do it quite slowly, just so it doesn't break the bottom of the beaker too, because of the weight.
But its density was only one advantage of this fascinating material.
Another thing that was crucially important for lighthouses was the fact that it was virtually frictionless. Is that true? What makes mercury, what gives mercury that kind of character?
So first of all, it's a liquid, so there's always going to be the less sort of kind of friction, and it's also got a really high surface tension as well.
Time to compare mercury to water.
So, whichever is most dense will sink. So there we go. The golf ball is denser than water.
Yeah.
I'll still pellet here. Sinks like a stone.
But how do they behave in mercury?
It's so weird. That is so odd.
Try push it down as well. And
try and push it down?
Yeah, of course, go for it.
And then, I'm not going to let go of it, but it just pops straight back up. Oi.
And now for the same test with the steel pellet.
Oh, wow. Just bobbing away.
Yeah.
Like a toy boat on a lake.
It's quite interesting to see a metal supported by another metal.
You can imagine scaling this up to the size of those mercury troughs they had in the lighthouses, and you could start to understand how they could support tons of weight of that glass on those lenses above.
But mercury is toxic, and interacting with it was another occupational hazard for lighthouse keepers in a difficult and dangerous job.
It's very stressful. If your light goes out, you're likely to have ships run aground. They were absolutely crucial, the lights, keeping navigation safe. And you as the lighthouse keeper, that was the responsibility on your shoulders.
There's no doubt that the lighthouse keepers were a special breed. Psychological fortitude was just one requirement of this phenomenally hard job. Keeping this complex machine in operation night after night, whatever the weather.
But who were the remarkable men who would leave their families behind and sacrifice their liberty for the safety of others. The building of the Bell Rock was no easy task, and once it was finished, it required at least 3 men to maintain the light. Marooned on the rock for weeks, sometimes months at a time, at the mercy of the elements in the cramped confines of a cold stone tower, who on earth would sign up for the job?
The idea of me going for a job as a lighthouse keeper, even my own family said, John, you're the lighthouse keeper, you're mad.
Lighthouse keepers had no control over where they served, and a posting on the Bell Rock was as tough as it came.
The Bell Rock was not a very popular station.
The reputation was, oh, no, the bloody bell.
Just getting onto a rock lighthouse was no easy task.
In the small hours of the winter morning, as I saw these men dressed in their oilskins going into a boat in the black dark, I just thought, this is madness. The men in these boats, this was their life. The mate was in charge of the boat, and when he snapped his fingers, you know, that was how the job was done. Just a look, right, Jim? Right. And that was it. And they knew what they were doing, and they were very, very sharp and good at their job.
And once they were into the lighthouse, things didn't get any easier.
Condition on the Bell compared to other lighthouses was hard. I was very lonely being out there, and a lot of people couldn't stand being locked up. It was like being in a prison. You couldn't go any place.
Psychologist Dr. Sophie Homer has studied the severe impact of solitary confinement.
Now, if we think about solitary confinement, for example, that's considered a punishment for a reason. And studies have shown that it really increases risk of experiencing depression, anxiety, anger. Now, of course, that's an extreme form of isolation, but thinking about our lighthouse keepers, they would have been so removed from their friends, their family, and their communities that it really would have been lonely work.
Rock lighthouses, like the Bell, were a far cry from a posting on the mainland.
I mean, if you were at a land station, you were there with your family. In my time, I spent 15 years on rock stations. I never got a Christmas with them in 4 years.
And the keepers had just as little choice when it came to who they served with.
I think we all have certain colleagues at work who we maybe try to avoid, but imagine being stranded effectively with them and confined to very close quarters. I think lots of us would think, no, thank you.
Foreseeing these kinds of problems, Stevenson had devised a way that the men on the lighthouse could communicate with the mainland. A signal tower on the edge of the harbour.
So if we look out to sea here, we can see Bell Rock
just
Lighthouse
there.
out there, just off to the right of that oil rig.
Yes.
How important was this signal tower and the buildings here to the Bell Rock Lighthouse?
It was incredibly important. It was an absolute lifeline. That was their only means of communication back to the shore again.
Does it work? Does this still winch up and down if you need to?
Absolutely, yes, it is still in working order. Would you like to have a go?
I'd love to have a go. Are we getting some movement?
Oh yeah, you can.
There he goes.
It takes a wee while to get started.
So there were 3 messages you could send with this.
Yeah, pretty much.
Everything's fine up the top. No, everything is definitely not fine. Nothing's happening, the ball's down the bottom. But half-mast, raised halfway, that was a specific signal about needing medical attention.
Yeah, that was like, oh, we need a doctor, we need someone to come out straight away.
But that expected communication between the tower and the lighthouse, that was what, only once a day that would happen at a set time?
Yeah.
So what would happen if something happened out on the lighthouse during the day that they needed to alert the tower about?
So they had a flagpole on here as well, and Stevenson devised this amazing book that had various different flags and means of communicating with the keepers on land. But one of the less official ways that the flagpole was used was that obviously a keeper would be on the Bell Rock, no communication with the land and his family. If his wife was expecting a baby and she had the baby while he was on the lighthouse, He wouldn't know whether it was a boy or a girl, so to let him know, they'd raise either a little pair of trousers or a petticoat on the flagpole so he could look over and see whether his wife had a boy or a girl.
Seriously, that was the kind of communication that could happen?
Yeah, and it's such a lovely personal thing.
That's really nice.
Despite frequent periods of isolation, for the men who could stick it out, being a lighthouse keeper was a job like no other.
I've got very fond memories of the Bell. I enjoyed my time out on the Bell. I used to lie there and watch the stars, and you can hear the thump, thump, thump of the ships going through, you know, struggling against the tide. And you can see the beam going round, and you just lie there. Oh.
After giving 32 years of my life to the Lighthouse Service, did I ever feel that I was doing a worthwhile job? Yes. The motto of the Lighthouse Service, in salutem omnium, for the safety of all. That was what we lived for.
The last lighthouse keeper left their post in 1998 as automation took over. But the lighthouses are still as important as ever.
So the Northern Lighthouse Board today is doing pretty much the same job that it was in 1786. We are here to protect the lives of mariners and to provide safe navigation. Although there's GPS, it's rather like driving a car. We still need curbstones and traffic signs to keep the driver safe. It's the same at sea. The mariner still needs a visual reference to look out the window and just that final check about where they are.
And Stevenson's legacy remains just as important as the lighthouses he built.
Stevenson was a great leader. It was, the Bell Rock and its keepers that came beyond really set the pace for the way we are today.
For Stevenson to have the original vision to do it, and for Stevenson to be the man on the reef most days to see it carried out, I think he deserves a lot of credit for doing that.
Now the world's oldest sea-washed lighthouse, with every passing year, the building of the Bell Rock becomes an ever more phenomenal achievement. The innovation and industry that built this tower also provided a blueprint for generations of engineers, which, like this lighthouse, continues to stand the test of time.
There's something very inspiring about the fact that these men went out to these places of huge darkness in order to raise a light to save lives. That's the best of us, that's the best of humanity.